Consider parasites at their largest population level. You have a whole population of hosts and a certain percentage of infection by a given parasite distributed throughout. And we're talking about generation upon generation for both species. In this context, the two variables of interest are virulence and transmission. Virulence is the amount of harm that a parasite does to the host while infecting it. And this obviously ranges across the entire spectrum. By definition, we have to be talking about harm because we're talking about a parasite rather than a mutual or a commensal. So the spectrum ranges from a teeny tiny bit all the way to killing the host outright. This becomes a little nuanced when we talk about life stages of the parasite and multiple hosts because this virulence can be extremely specific per stage and host. Transmission, the other major variable, is the extent to which the parasite travels from host to host within the host population, and this can be nuanced by the direct movement of the parasite just going from one to the other, or it can be a matter of parasite reproduction in which offspring or eggs of the parasite are evicted from the host in some way and picked up by another to mature elsewhere. These are still the basic idea being moving from host to host. And the variable in question is a matter of rate. How fast does this happen? How often does this happen? And then you have subvariables like contagion and resistance and a variety of other things. How do these two variables interact? At the coarsest level, the most simplistic, the faster the transmission, the more virulence is possible. The logic being that if transmission is quite slow, then across the population, the hosts would be killed off by high virulence prior to transmission occurring enough for the parasite to reproduce successfully. And this seems to apply when we see parasites with slow transmission rates, then we typically see parasites with lower virulence. There are ways to do end runs around this situation. Also, it doesn't necessarily mean that high transmission means high virulence. But the prevailing logic suggests that unless transmission is rapid, then higher virulence can't evolve. Again, though, a great deal of research suggests that end runs and edge cases of these relationships are common.